In this tutorial, I'm going to explain about the temperature reading of temperature from the atmosphere by using thingsio.ai cloud platform and ESP32 module. The ESP32 board has inbuilt sensor like the hall sensor, which is used for proximity, temperature sensor which is used for measuring the temperature in the atmosphere, and touch sensor. And this is the block diagram of ESP32. So it has touch sensors, temperature sensor, a hall sensor, and inbuilt Bluetooth and Wi-Fi modules, which is not there in a Node MCU. So we can measure the temperature by using ESP32 by simply writing a code. So for that, for sending the values into the cloud, all you have to do is you have to just, if you are new to this cloud platform, then you have to register. The registration process is quite simple. What you have to do is just give your name, your mail address, and then the contact number. They will send a verification mail, so if you access it, you can activate your account. So already I have done a few projects, so I am just logging in into this cloud platform. So here, to create the new project, what you have to do is just tap on this new project button and then give your project name. You can give any of your name, but here I am giving it as 4. And then you have to create the device name of B maybe of your choice, like I am giving it as 4D. And then the device ID, which is a very important parameter here. So with the device ID, you can send the values right from the board to the cloud platform. It acts as a medium. So we have to create and configure the device. So the parameter which I am giving is temp is a parameter and it is of integer value. Since the temperature is in integer, you can give a decimal value, and then you have to select the energy parameter and then update the device. So the device has been updated successfully. You can see that there is no values and it is showing the status as no data received yet. So for this, you have to give a code. The Things Cloud has predefined sample codes like for different boards like Node MCU, Raspberry Pi, and ESP32. Here I am taking the ESP32 and then copying the code and then pasting it in my Arduino IDE, and then make some necessary modifications for according to my sensor. So here I am using the modification which I am using here. I am mentioning some more libraries in order to read the temperature from the inbuilt temperature sensor. So the changes which you have to make here is you have to give your Wi-Fi name and then your Wi-Fi password, and write the code according to the temperature, according to the value, and then here you have to mention the device ID. So the device ID which I am accessing is here. You must copy the device ID and then paste it here. So here the parameter should be mentioned. Here I am giving the parameter as temp. There I have mentioned it as temp, hence you have to match both of it. So and then you have to upload it. Before uploading, you have to check if your board you are using is being selected correctly or not, and then you have to select the COM port. Since I didn't insert it, the COM port is showing blood, so I just have to insert the board. And then Now the comport is available. So you just have to upload the code. You need to compile first and then upload, but here you can upload it directly, since it will do compilation first and then uploading next. You have to tap on this boot button for certain amount of time and then release it, so that the new code gets uploaded into the board. Since the ESP32 board cannot erase the previously entered program, we have to do it manually. So we have to press the enable button and then the code gets uploaded. Since the Wi-Fi is slow, so we have received 200. Okay, that means from the server side the values has been accepted. So what you have to do is just now we'll check if the values has been sent into the cloud or not. So for that, so this is my device, and then so these are the values which I got. This is the bar graph representation of my values, and then we can create our graphs by using the create graph button, which is present in here. So this shows the line graph representation of the temperature. This is the temperature value and this is the time. So you can create your own custom graphs, whether it can be a single value or multiple values, and then you must give the graph name. So this is the graph name I'm giving, and then the parameter. We'll just see a quick review of the obtained values from the sensor, and then the graph will be created. From the graph we can evaluate for which areas of the sensor can be used, and we can measure the temperature and then make some necessary changes. Thank you.